Oh, hello friends. Uh, Actually, this video is built with the content that we have to discuss. Many of students asked about what is mean by the Pascal triangle, what are its applications, and what is the use of the same binomial coefficient. So first, we will start by using what is mean by the Pascal triangle. Actually, both the concept used in order to expand the term. What is the term? This one a plus b to the power n. So this term, for expanding this term, we have to the questions like what is the coefficient of the power a to the power something n into b to the power n minus 1, or a cube into b to the power some n minus 3. Okay, so this type of question may be asked in the exams, many competitive exams, and in order to find such a coefficient, we have to use of these two concepts. What is the first one is the Pascal triangle, and second one is the binomial coefficient. Actually, binomial coefficients are identified or find with the help of the concept Pascal triangle. There are the two formulas. First one is the Pascal triangle. So we will start with the Pascal triangle. Nothing but Pascal triangle is nothing but arrangement of the numbers in this triangular arrangement. What is this? The sides of the triangles are two sides of the triangles are what? 1 1. These are 1 1 1 1 1 and 1 1 1 1. Let us see here. Okay. And here addition of these two numbers is nothing but this number, and this is what? 2. This is what? 2. Now here addition of 1 plus 2 is what? 3. Addition of 2 plus 1 is what? 3. Now addition of 1 plus 3 is 4. So how this works? Actually, this works in this example. You will see that expansion of a plus b bracket square is, we know that a square plus 2ab plus b square, and this is nothing but this row 1 2 1 1 2 1 1 2 1. Similarly, here you can see that a plus b bracket cube is equal to a cube 3a square b plus 3ab square is plus b cube. Now here you can see here third term, third row. In this third row, you can see that 1 3 3 1 here 1 3 3 1. So this is the simply use of the Pascal triangle, and the sides of the, and in order to write the Pascal triangle, we have to first write the two sides, and it has the entries 1 1 1 1 1. Another side has the entries 1 1 1 1 1, and middle one start with the addition of previous two terms, that is 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, and so on. We get the Pascal triangle, and using the Pascal triangle we can find any terms. Okay, now here in an example, expand a plus b raised to 5, we use the sixth line of the Pascal triangle. So write this triangle to the sixth term. So this is the first, second, third, fourth, fifth, and after that you will get the sixth term, and here you will get, yes, 1 plus 4 is 5. Now here is 1. After that 1 plus 4 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 1 plus 4 is 5 and 1. Here we get 1 5 10 10 5 1. Observe this triangle. First one is 1 1 1 1, so here we will get 1. After that addition of 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and 1 as it is. So we will get the entries 1 5 10 10 5 1. 1 5 10 10 5 1. So this is the use of the Pascal triangle to expand a plus b raised to 5. Expand. Now here is the next example. Now here some remark is there. Notice that the power of a and b in each term always adds to n, where n is the power to which a plus b is raised. In the above example, we can say that power of a and b in each term always adds to 5. What it means? Here What is the expansion? Expansion is about a plus b raised to 5, and this remark says that addition of the power, that is addition of a raised to 4 and b raised to 1, that is 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and here is the term 5. So addition of power is always the expansion term. This remark says that. Okay. Now here question is that expand 1 plus x raised to 4 using the fifth row of Pascal triangle. Using the fifth row of Pascal triangle. What are the entries in the fifth row? Here are the entries 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Yes, very simple. So use of the Pascal triangle is very simple. But there are some tricky questions which may be asked in the exam, and you have to identify that this question may be solved by using the Pascal triangle. So this is the beauty of the mathematics. This is the beauty of the Pascal triangle. You have to only identify which row we have to be use. Just by identifying the rows of the Pascal triangle, you can solve the expansion very easily. Now here expand the expression. The fourth row of Pascal triangle is, so yes, you can use the fourth row because cube term is there, and for the cube term you have to use next, that is 3 plus 1 row of the Pascal triangle. So these are some similar examples. Yes, you can solve these examples also. Now here the binomial theorem. Calculating the coefficients in the binomial function a plus b raised to n using the Pascal triangle can be take a long time for every mandatorily large n. For example, it might be take you a good 10 minutes to calculate the coefficients in x plus 1 raised to 8. Instead, we can use that we know about the combinations. Yes, what it says that, it says that if you are saying that I am using the Pascal triangle, then it may be a time taking process. So is there any alternative method? Yes, there is alternative method. By using the combinations, you can find that directly the coefficient, because every time you have to write the Pascal triangle starting from the first entry, first row, second row, third row. If you are finding the power of x plus 1 raised to 39, then you have to write 40 rows in the Pascal triangle, which may be a time consuming process. So by using the Pascal triangle, you can just use one formula. Using that formula, you can find just the coefficient in the binomial expansion. That is the binomial theorem. Binomial theorem is just what? It gives the formula, combination formula using, so that we will get the direct formula of the binomial coefficients. Okay. So what is the theorem? It says which will be discussed in the notes. Okay. But here we are saying that what is the binomial theorem? Binomial theorem is just used. Binomial theorem is just used to find the coefficients in the binomial expansion. Okay. Now what is that formula? Here is the formula NCK. Yes. The binomial theorem gives a general formula for expanding all the binomial functions. So x plus y raised to n is equal to summation runs from I equal to 0 to n NCI x raised to n minus I into y raised to I. So by expanding this term, we will get this. So every time we will get NC0, NC1, NC2 up to so on. This is the rth term. So how to use this formula? Just take an example. Expand this x plus y raised to here. Just simply NC0, NC1, NC2, NC3, NC4, and you have to just adjust these terms. You have to just adjust these terms. Okay, this is now expand this one just using binomial. You can see that you will easily find the expansion of this. Yes. Find the coefficient independent of x in this expansion. Yes, the binomial theorem tells that which is this expansion, and you have to find the coefficient of x only, which will be the, you have to just take some modifications, and which will be, so the power of x is 4i minus 20. We need to set here, you can say that. Okay, and what the coefficient of x. Okay, so when we get x equal to 1 here, so I equal to, if we take 5, then we get, this will be the 0th, so 20. If I equal to 5, then we get the required result. So 20c5 into 2 raised to 15 is equal to this one. This one is the coefficient of x. So these are some examples for which you can just use the binomial formula in order to find the coefficients in the binomial expansions. Okay, and this is from my side. Thank you.